Hey everyone, welcome to another video. Today we will talk about linked lists. In our previous videos we have talked about arrays. If you have not watched our videos and you want to learn about arrays, please go and watch it. I have added the link in the description box. So now coming back to linked list, what is a linked list? Now if you remember arrays, in this one we discussed that the data is stored in contiguous memory location. Like if this is my array location, so this, if the address of this element is at 0, I know that this address will be 1, this will be 2, and so on. But linked lists are not the same. So linked list allocates memory randomly, and the size of the linked list also varies dynamically. For example, this is actually a linked list. And I mean, this is a linked list of size 4. The first element is called the head of a linked list, and this is the tail of the linked list, right? Okay, now what this element is called, I mean this one element, now this is called a node. What is a node? A node is a complex data structure. Again, I created a video about different types of data structure. If you haven't watched, please go and watch that as well. I'll just explain what is a complex data structure in a brief here. So complex data structure is a combination of different primitive data structures. For example, let's suppose take a very basic example. This node consists of a integer type of data, and that's it. Yeah, this is only integer. And node also contains a pointer to the next variable. So pointer, basically it's a node next, and this is a typical node structure. Now let's see the linked list again with specific node structure. So for example, this is my one node, this is another node, and this is another third node. Let's take three examples only, 3 nodes only. This is my head node. Now this contains, let's suppose value is 7, this contains 4, this contains 9. Now this is my next pointer. This will actually, what the pointer will store is, this will store the address of my next node. So this will store the address of this node. I mean, I'll just erase it, this node. This will store the address of this node. And since this is my last node, this will store the value null. Okay, that's how a linked list is. And so if we have the head pointer, we can easily traverse the complete linked list. Now there are very different kinds of linked list. For example, there is a single linked list which we just studied. There is a doubly linked list in which there are 2 pointers, next pointer and a previous pointer. Using the next pointer we can go to the next element, and using the previous pointer we can go to the previous element. The advantage of the doubly linked list is we can traverse both in the left to right, basically in the next traversal as well, or we can move backward as well, right, starting from the head. So this helps in traversing. And again, in a single linked list it's not possible. The third type of linked list is circular linked list. Circular. And that linked list is, you can say that this is my linked list. The last element will again point to the first element. So in a single linked list, you basically see that the last element points to null, but here the last element will point to the first element only. So that's a circular linked list. So basically there are 3 types of linked list: single, double, and circular. Now what are the advantages of a linked list over arrays? If I talk about the advantages, so in array we know that it has a very fixed size, but in linked list we can have dynamic size. It can change with the amount of element it contains. The second is efficient insertions. and deletions. So deletions, these are the two advantages, like we can easily insert or delete an element. Now how it is easy is because again it comes to this size advantage. So basically in this array, if we have this 1 2 3 4 5 elements, let's name it as 0 1 2 3 4. If we want to delete this third element, this one, so the array will become 0 1, this will be empty, 3 4, right? So this is a waste of memory. Now in the linked list it will be as this is my linked list. I want to delete this element and it will be this linked list after the deletion, and same goes for the insertion. So if insertion I want to add a sixth element in the array, I have to create a new array with 6 size and then add. But in the linked list I can just create a new node and add it in the linked list. That's it. Now talking about disadvantages. So it has, like, we cannot access any element based on their index. We have to traverse the list from the head to that element. So if this is my linked list and I want to reach, let's take one more element, I want to reach this element, so I only have the head pointer. I have to traverse the list till this element to reach this element, while in array I can just simply access this element using the index. The memory usage per element is high because we are storing another data pointer, and which is an address of the next node, so the memory usage is higher. So yeah, these are the advantages of a linked list. Now basic operations in a linked list, again, I mean, I think it's very generic one. Maybe you already know that it's a traversal. If we have to traverse the complete linked list to maybe print the data of the linked list. Insertion, deletion, or searching the element in a linked list. These are the 4 basic query operations. Alright, so this is the sample code of a linked list. In this we have implemented all the 4 functions: traverse, insert at, delete at, and search. In the traverse we are starting with the head node, and we are traversing until the current node is null, and we are just printing the current element and moving to the next pointer. In the insert at, we are using a 0 based indexing. It means that the first element is indexed at 0, and we take 3 parameters: head, int data, and the position at which the data needs to be inserted. So if the position is 0, this is the new head, else it will insert the element into its position. It will traverse the linked list to that position and insert that. Delete at, so it will delete the element from the given position. And search, basically it will search the element with the given key. Now let's discuss insert and delete functions. We'll take an example here. So let's suppose we have a linked list of size 5, or let's take this example only, what we have taken in the code. So we have this 3 size linked list. We have the first element is 10, second is 20, and third is 30. Alright, now if you want to insert a 4th element, 40, then what it will do, so we have the head at 10, and we have current starting from 10. Let's take this position as this is the current position, which is 0, and the position which we are giving as input is 4. So these are our input parameters, 40 and 4. Alright, now we are at the first index, first element, the position is 0, current equals to 10. It will go to the next position. The current is now 20, position is 1. It will go to the next position. The current is 30, position is 2. Oh, actually we have to give 3 as a position because it's a 0 based indexing. So current dot next contains my next element pointer to the next. Now if we have to add a new node here, so this pointer needs to be deleted, the new node needs to be added. This will point to the new node, this element, and this next will move to this one, so this will point to the next node. So current dot next value, so the new node dot next is equals to current dot next, and current dot next equals to new node. This is how we will insert a node in the linked list. For the deletion also it works similarly. Let's suppose we take this example again, 10, 20 and 30, and let's suppose we want to delete this element now, 20. So what we'll do is we will move to this element, basically we will move to this element 10, which is one position less than the element that needs to be deleted. So this will be our current element. Now current dot next is this element 30, and my current dot next equal to this. So basically current dot next is 10 pointing to 20, which will now point to 30. I'll show it with a different color here. So this will point to 30, and the final linked list will be 10, 30. So our element 20 is deleted. So that's how the delete will work. Thank you.